Okay, so we're going to talk about the special right triangles on a unit circle. Essentially, what we're going to do is we're going to look at two special right triangles. We're going to slam them onto the unit circle, and we're going to use those to kind of have some a stockpile of angles that we already know sine and cosine of, instead of having to always go to the calculator and type in, oh, what's the sine of this? What's the sine of that? Two special right triangles. The first one is the 30, 60, 90 right triangle. And the reason why the 30, 60, 90 right triangle is one of the special ones, one of the ones that we pick, is because it has a known ratio of its sides. Because if I do this, its hypotenuse is 1. On all of these special right triangles, we're going to have the hypotenuse be 1. So that way, when I bring it over to the unit circle, it's going to have the same, or the hypotenuse is going to be the radius of the unit circle. So that's good. So here we go. So I'm going to put this on here over here, the 30 degree or the 60 degree right triangle. Boom. Okay. Now let's see. Did I do that right? How well did I do that? Well, if this is 1, okay, a 30, 60, 90 triangle comes from splitting a 60, 60, 60 or an equilateral right triangle in half. Okay, so if this is 1, then this is going to be 1/2. So did I get about halfway out? Is this x coordinate about half? I think I did a pretty good job, actually. So I'm going to go right here. This is 1/2 right there. So that's my 60 degree right triangle right there. And then this piece here, you can do a little bit of math to get to it. If you want, you can solve this. 1/2 squared plus the height, well, we'll say the b squared is equal to the hypotenuse squared, which is 1 squared. Or right now, what do we know about this point? This point has an x coordinate of 1/2. That point has an x coordinate of 1/2. And what do we know about all the points on the edge of that circle? We know that x squared plus y squared is equal to 1, because that's the equation of that circle. So if you notice, if I put 1/2 in there, that's the same, turns into the same equation here. The b is just the y coordinate on that thing. Okay, so we work this out. We end up with b is equal to the square root of 3 over 2. Okay, and you can work that out on your own. It's not the square root of the big square root. It's just the square root of 3 over 2. You can work that out on your own on some time, just solving that piece. But I'm not going to go through that here. You guys can do that on your own. So that means that the y coordinate is square root of 3 over 2 for that point. Okay. We still, in all of these lectures so far that we've talked about, we have not yet said anything about sine or cosine. We've just been putting these silly triangles and getting rotations around here. Well, and we're still going to do that for just a little bit. So first of all, so this is 60 degrees. 60 degrees there. I want to talk about its family right now. So let's see, what were its families? Quadrant 1, the family number was 60 degrees. If I drew that 60 degree triangle in quadrant 2, if I draw this in quadrant 2, let's see how good this is. I need to go out, let's see, this is the nice thing. This is 1/2 right there. So I know kind of where to put these, because I just have to go straight up from that 1/2. Right there. So those are my 4 triangles. Kind of make a little bow tie thing. And then we know that all of these triangles essentially have kind of the related coordinates at least. And again, they're always coming, the right angle is always sitting on the x-axis. We don't want to put those on the y-axis at all. Okay, so this is negative 1/2, and then we know this is the square root of 3 over 2. And this is negative 1/2, and the negative square root of 3 over 2. And this is 1/2 and negative square root of 3 over 2. Good, great. Okay, so now what we got to do is we got to figure out what these angles are, what these reference angles are. So quadrant 1 is 60 degrees. Quadrant 2 is 60 degrees off of that 180 mark, so back from 180, so that's 120 degrees. Quadrant 3, that's 60 degrees past, a 60 degree rotation past 180, so that's 240 degrees. And quadrant 4 is the family member is 60 degrees back from 360, or 300 degrees. So all those triangles are related. All those triangles have the same x and the y coordinate, or related x and y coordinates, just maybe off by a negative. Okay, so let's go now to the trig. Why does trig come into this? Well, we all know, we used it before, that the sine of an angle, and I'm going to use this Greek letter theta, T-H-E-T-A, theta, to represent my angle of rotation, is equal to the opposite side divided by the hypotenuse. Okay, the opposite side divided by the hypotenuse. So what's interesting here is that on the unit circle, when we're dealing with the unit circle, the hypotenuse is always 1. Hypotenuse is always 1, the way we draw our triangles. So in this case, the sine of 60 degrees is equal to the opposite length, which is square root of 3 over 2, over 1 for the hypotenuse, or the sine of 60 is just square root of 3 over 2. If you did it on your calculator, it wouldn't tell you square root of 3 over 2. It would tell you, let's see, square root of 3 over 2, isn't it 0.866 or something like that? We'd have to go through. And that would be the sine of 60 degrees. The cosine of an angle is always the adjacent over the hypotenuse. So that means that if I took the cosine of 60 degrees, that would be, it's right here, 1/2. 1/2 over 1. So then the cosine of 60 degrees is just equal to 1/2. So here is how this all shakes out. It turns out, go ahead. It turns out that really, when you dealt with the sine and the cosine on right triangles in the past, all of the acute angles, all the angles that you were looking at, were all between 0 and 90 degrees because they were a right triangle, they wouldn't fit. But it turns out that theta cannot, or may just mean the angle of rotation. So we can actually expand this now, and we can go to the go into the second quadrant, and even into the third, and even into the fourth, and evaluate what the sine and cosine of a given angle of rotation is. So I'm going to erase this stuff, maybe. A little warmed up spray. Yeah, it's still springtime, still a little cold. So now, put this here, grab this out. All right. So now we're looking at the, let's say I want to talk about the sine of maybe the quadrant 3 angle, 240 degrees of rotation. Well, the true definition of sine, or one way that you can define sine, the unit circle definition or a circle definition of sine, is the angle of rotation, the sine of the angle of rotation is equal to the vertical position, which is the y coordinate, over the radius of the circle. The y coordinate over the radius of the circle. So the sine of 240 degrees is going to be related to the sine of 60 degrees, because 240 and 60 make the same triangle. And I know that this leg, the vertical leg of a 60-degree triangle, of a 60-degree family triangle, is going to be square root of 3 over 2. And if I'm on the unit circle, that's going to be 1. So this is just square root of 3 over 2, and it's going to be a negative because we're in the third quadrant. If I wanted to take the sine of 120 degrees, that's just the y coordinate divided by the r. The y coordinate, 120 degrees, the y coordinate is going to be square root of 3 over 2, and it's going to be positive over 1. So this is just going to be square root of 3 over 2. And then lastly, the sine of the quadrant 4, 300 degrees, is going to be the y coordinate, which I know is going to be some version of square root of 3 over 2. And because I'm in quadrant 4, that's going to be a negative y coordinate over the radius, which is 1. Notice the radius is always positive. So this is negative square root of 3 over 2. So by knowing the 60-degree triangle, we actually get 3 more pieces for sine and cosine. We get more, the reference angles, pushing those into the other quadrants, give us more information. All right. So what are we going to do now? So right now we have one angle. We have one family of angles that we know the sine and cosine for. Okay. So let's get another family of angles. And this other family of angles now is going to be, actually, I'm just going to turn this triangle on its side, this triangle on its side, and we're going to talk about the 30-degree family. I can see I'm going to just, it's going to be faster this way. All right, nice thing that we have here, working in the garage, we get a nice bucket to make circles with. So we're going to make this circle. All right. Right there, there's my unit circle. And we know that this is the point 1, 0. We'll just do that just so everybody knows that the radius is 1. And we know that it is, the equation for this is x squared plus y squared is equal to 1. And what I'm wondering about is the 30-degree family. Can I tell what the x and the y are at that 30-degree family? Can I tell what the opposite and the hypotenuse are? Sorry, the opposite and the adjacent are in this situation. And the answer is yes, because it's a 30, 60, 90 triangle. What do we say about the short leg? That's just going to be 1/2. And the long leg is square root of 3 over 2. Because it's square root of 3 over 2, or square root of 3 times the short leg. So that's just square root of 3. So now this ends up being 1/2. Sorry, square root of 3 over 2. One half. That's what you got. So what's that help me with? Right now, what do I know? I know because of how that all shook out, because that's sitting there, for an angle of rotation, the sine of 30 degrees is the y coordinate over the hypotenuse. So y coordinate over the radius, which is just going to be 1/2 because the radius is equal to 1. The cosine of 30 degrees is equal to the x coordinate over the radius because that's the adjacent leg over the hypotenuse. The adjacent leg to all of these triangles is the x coordinate. So this is going to be square root of 3 over 2. But we got the whole family that we can do. Now that we have 30 degrees, we can do the whole family. So what angles can we do this for now? Well, in quadrant 1, we can do it for 30 degrees. In quadrant 2, we can do it for 180 minus 30 is 150 degrees. If I rotate into quadrant 3, 30 degrees into quadrant 3, that's 210 degrees. And quadrant 4 is going to be 360 back 30 is 330 degrees. So now if somebody says, what is the cosine of 330 degrees? I'd say, oh, wait, I know that's a family member. That's the 30-degree family member. And I know for a 30-degree triangle, the x coordinate, because it's cosine, the adjacent leg is going to be square root of 3 over 2. So this is going to be square root of 3 over 2. Now I have to think, was this what quadrant was this in? This was quadrant 4. Since that was quadrant 4, that's going to be a positive x coordinate. So my x coordinate is square root of 3 over 2, and then I can say over 1, but nobody cares about over 1. As long as we know it's over 1, we're okay. How about if I did the cosine of the quadrant 2 family member? Let's say 150 degrees. Well, that's quadrant 2. I know that that's a part of the 30-degree family, and I know that all the 30-degree families have that triangle to be square root of 3 over 2. So square root of 3 over 2, and it's going to be negative in that situation because in quadrant 2, all the x coordinates are negative. All the x coordinates are negative in quadrant 2, so we can say that we're set there. All right. So now we're going to mess around with this a little bit, and we're going to say, what happens? There we go. So let's just kind of, again, now our new definition for the sine of an angle is equal to the y-coordinate at the rotation divided by the radius. And the cosine of an angle is the x-coordinate divided by the radius. When you rotate it around a circle of radius r, something like that. So it relates the x and the y coordinate, the horizontal and the vertical position of a point, to how far that point has rotated around a circle. So let's go ahead and draw my circle back up again. Oh. This one slid a little bit on me. We'll see. Oh, not too bad. So there's my circle. There's that. Okay. So one more that we're kind of responsible for, and then we'll talk about the quadrantal angles too. Okay. So the other one that we have is the half of a square. And this square has a hypotenuse of 1 because that's where we get the right triangle. Remember, we want all the right triangles that we put on here, on this, to have a hypotenuse of 1 because when we draw them in here, we need the radius to be 1. Okay? So what are these? If I got a hypotenuse of 1, if I have to have a hypotenuse of 1, what's this going to be and what's this going to be? What's this? Well, this is 45 degrees because it's half of 90. I think you had that before. Well, let's call that, let's see. We know this number and this number are the same. So I'm going to call that L and L, the two legs. So let's see, we know that L squared, or we can plug it in up there. Okay, we can plug it in up there. Ooh, that's kind of an interesting thing. On a 45-degree line, does it make sense that the x and the y would be the same? Well, a 45-degree line is the line y equals x. So I think it does. So that's good. So plus L squared is equal to 1. 2L squared is equal to 1. So L squared is equal to 1/2. And I'm probably boring you with this. So L is equal to the square root of 1 over the square root of 2, which is 1 over the square root of 2. And then we have to rationalize. So square root of 2 over square root of 2. And square root of 2. And then that's equal to square root of 2 over 2. So there's where we're sitting there, square root of 2 over 2. So this side is going to be square root of 2 over 2. And this side is going to be square root of 2 over 2. And we're set. All right. So now we get a 45-degree triangle. If it's a right triangle with 45 degrees and the hypotenuse of 1, it's square root of 2 over 2, square root of 2 over 2. All right. Get rid of this. Okay, so now, so if this is 45 degrees of rotation, what is the coordinates of this point? We said that going out would be square root of 2 over 2. So that's the x coordinate. And going up would be square root of 2 over 2. That's the y coordinate, square root of 2 over 2. All right, so let's talk about the family. Quadrant 1 family member is 45 degrees. Quadrant 2 family member. Go ahead and just take a minute. Figure out quadrant 2, quadrant 3, and quadrant 4. Quadrant 3 and quadrant 4. Pause the video for a second and see if you can come up with that. Okay, hopefully you came up with that. And now we've got, you said, okay, now I'm going to rotate here to 180 degrees and then back 45. So that's 135. And you rotated all the way to 270 degrees and then, sorry, all the way around to 180 degrees and then another 45 degrees. So that's 225. We're not going to rotate to the Y. We're always going to go off of the X. So we got to be 45 degrees away from the X. So we're going to go 360 and back. So that's 315. All right. So now we've got the four quadrant members or family members. So now if somebody would say, well, what is the sine of 315 degrees? You'd say, hey, I know that's the 45, it's part of the 45 degree family, and it's the quadrant 4 member of the 45 degree family. So since it's the quadrant 4 family, well, since it's the sine, that's the y coordinate over the radius, and the y is equal to square root of 2 over 2, and the radius is equal to 1. So this is square root of 2 over 2 for sure. And in quadrant 4, the y is positive or y is negative? Well, all coordinates down here, all the y coordinates are negative. So that's a negative value right there. What if they asked us for the cosine of 135 degrees? If they ask us for the cosine of 135 degrees, well, let's see. 135 is in quadrant. That's definitely the 45 degree family member, and it's in quadrant 2. It's in quadrant 2 family member. Well, I know the cosine is the x coordinate. The x coordinate for any 45 degree triangle is square root of 2 over 2. And now since I'm in quadrant 2, the x coordinates are all negative. Okay. So now are there some things that you have to get used to here? For sure. There's some definitions. There's some defining things that we've seen. Specifically, we defined these two. You have two new definitions for sine and cosine. And it's not an understanding piece at all. That's just a definition. We've defined them to be that. Now, some of this stuff, quadrant 1, quadrant 2, quadrant 3, reference angles, that's understanding. That's figuring that out. We got to add our understanding into it to do some of these evaluations. All right, so the good thing about that is that that's it for the triangles. Those are the only special ones we have to worry about. Now, in your packet, or you can find a quadrant 1 unit circle just about anywhere. Okay, or you can find a full unit circle anywhere. If you just search unit circle, trig unit circle, you'd probably find one with all the coordinates in it, and it would have all kinds of information on it, and you'd be able to just kind of look it up. That'd be pretty good. Be pretty good information. So let's see. What I want to do right now, though, is I want to make sure that we get these also in radians, because we know we measure angles in radians as well. So the last piece of this is just really showing you where, or the family members in radians for these special angles. So let's see, we had three special angles there. So I'm going to draw 3 triangles here, or 3 circles for us. 1, do this one here, maybe it'll look like Mickey Mouse. 2, and 3. Now what's nice, and maybe you haven't thought of this before, but I do it a lot when I'm on, when I'm working on trying to learn stuff from the internet. Feel free to adjust that thing so it is, adjust the speed of the playback so that you could to match how fast you can take in information. If you can take in information at 1.5 speed, why not do that? Make sure you get in there. Use that as a tool. If you can learn 50% faster, you can get that information 50% faster. Why wouldn't you do that, right? Or 25% faster? No problem. You can always pause. I wouldn't look at this any slower than that. Okay, 1.75, it starts to get fast. 2 gets really fast. It gets kind of funny. Okay, so here we go. So now we're going to talk about the 30-degree family. So we'll do this one, the 30-degree, and we'll talk about this one as the 45-degree family, and this one is going to be the 60-degree family. But now we got to get in those radians. Okay, So 30 degrees is 1/3 of 90. That's the way I think about it, is 1/3 of 90, okay? 90 is pi over 2. You got to have that locked in. So we know that this is pi over 2 up here. This is a rotation of pi over 2. This is a rotation of pi over 2. Okay, so 30 degrees is 1/3 of 90. So I got to take 1/3 of pi over 2. What pi over 2 times 1/3 is pi over 6. So this thing that's a 60-degree triangle, that's a 30-degree triangle, that's pi over 6 radians of rotation. Pi over 6 radians of rotation. So now quadrant 1 is the family member is pi over 6. Quadrant 2, the family member, let's see, that means the pi over 6 family calls this spot 6 pi over 6. Okay, it doesn't call it pi, it calls it 6 pi over 6. 6 pi over 6. So in quadrant 2, if I spin to 6 pi over 6 and back 1 pi over 6, that gets us to 5 pi over 6. If I go to quadrant 3, that means I got all the way to 6 pi over 6 and I went another 1 pi over 6, or another 1/6 of pi. So I got to 7 pi over 6. And then quadrant 4, I got all the way, what's this family? The pi over 6 family calls this 12 pi over 6. 12 pi over 6. So if I spun all the way around to 12 pi over 6, but then I need to come back off the axis pi over 6 to make the triangle, that's going to be 11 pi over 6. So there's your family members there. So let's just put in the middle here, this is my little work box here. Let's say somebody asked you, well, what's the sine of 5 pi over 6? You'd say, okay, well, the pi over 6 triangle, that's kind of this short one, and I know that it only goes up a half. So I know it's a half, but I don't know if it's positive or negative. 5 pi over 6. Well, 6 pi over 6 is division between, is right here. So I'm always thinking about 5 pi over 6. Well, let's see. This is 6 pi over 6. So I must be in quadrant 2. So that's still positive in that situation. So we do that. If somebody asks me, what's the cosine of 11 pi over 6, I'd have to, again, remember about this triangle right here. This triangle right here has square root of 3 over 2 for its x and 1/2 for its y. So I need the x coordinate at 11 pi over 6 over the radius. So the x coordinate anywhere is square root of 3 over 2. The size of the x coordinate is square root of 3 over 2. Now 11 pi over 6, where is that? Well, let's see, 6 pi over 6, okay, so if I go, it's not 5 pi over 6 and 7 pi over 6, so it's not in these two. So then let's go over to 12 pi over 6 and then come down, oh yeah, 11 pi over 6 is in quadrant 4. Quadrant 4, this is a quadrant 4 angle, has positive x values, so we're in good shape there. So that's how you would use that, and that's the same thought process as we did before. What's the reference angle? What's the reference angle, and what quadrant does it live in, and what do you want, the x or the y? All right, so 45 degree, well, one real quick here. It's nice with pi over 6 family because any family member that's part of the pi over 6 family has a denominator of 6. Okay, any family member in the pi over 6 family has a denominator of pi over 6. So if I see 7 pi over 6 or 12 or 13 pi over 6, I already know it's part of the pi over 6 family. That's really good. Okay. All right. So we're going to look here. All right. 45 degrees. Well, that's pi over 2. So 45 is half of 90. So I can go half of that. So this angle right here. Ooh, that one's bad. We got to go half of that angle. So half of that angle, half of pi over 2 is pi over 4. So pi over 4, and I know that the 45 degree triangle here has square root of 2 over 2, square root of 2 over 2 for its coordinates. Okay, so then all its family members have some version of square root of 2 over 2, comma square root of 2 over 2 for its coordinates. So let's just go through, let's see, let's see, in this quadrant 1, I'll go up here. In quadrant 1, it was pi over 4. In quadrant 2, so this family calls this spot calls it 4 pi over 4. 4 pi over 4. Because we know that it's really pi, right? It's really pi to get to that spot, to get to that rotation. So then it's really 4 pi over 4 when you're trying to get, we're trying to get the reference, use the reference signal pi over 4. All right, so now if we spin to 4 pi over 4 and come back pi over 4, that's 3 pi over 4. If I spin to 4 pi over 4 and I go a little bit past, that's 5 pi over 4. What's this place call it? Yep, you're right, 8 pi over 4. Because that used to be called, we call that 2 pi. We know it's 2 pi, but the pi over 4 family calls that spot 8 pi over 4. So if I go all the way to 8 pi over 4 and then come back to get into the fourth quadrant, that's going to be 7 pi over 4. Always think about that rotation. 7 pi over 4. So again, now we can come up with what's the cosine of 5 pi over 4? What's the sine of 3 pi over 4? Things like that. We know that the values are always going to be square root of 2 over 2 and square root of 2 over 2. We don't know if they're positive or negative until we know the quadrant that they're in, and we can always tell the quadrant by what family member we're looking at. All right, 60 degrees. Well, 60 degrees is 2 of the 30s, right? So if I take 1 pi over 6 plus another pi over 6, if I take a 30 plus a 30, I'd get to 60. If I take pi over 6 plus pi over 6, I would get to the equivalent of 60. So 1 pi over 6, 2 pi over 6. 2 pi over 6 is pi over 3. So this is going to be a pi over 3 deal. Pi over 3. So what do we know about the 60-degree family? That was only a half over and square root of 3 over 2 up. So 1/2 over and square root of 3 over 2 up, just like that. So now what are the family members here? Quadrant 1 is pi over 3. Quadrant 2, let's see, I have to go all the way to, well, what's this? This is normally pi, but the pi over 3 family calls that 3 pi over 3. So if I rotate the 3 pi over 3 and then come back into the second quadrant to get my quadrant 2 number, that is 3 pi over 3 minus pi over 3. That's 2 pi over 3. And quadrant 3, if I go to the 3 pi over 3 and add pi over 3 to it, that's 4 pi over 3. And quadrant 4, this spot over here, normally we call that 2 pi, but the pi over 3 family calls that 6 pi over 3. So if we go to 6 pi over 3 and come back, that's 5 pi over 3. So it's all about those rotations again and thinking about those quadrantal angles. So now if somebody asks me, what is the sine of 2 pi over 3? What's the sine of 2 pi over 3? Well, it's the y coordinate, and it's part of the pi over 3 family. So I know it's going to be square root of 3 over 2, but 2 pi over 3 is in the second quadrant, so it's positive square root of 3 over 2 because all y coordinates are positive in that situation. All right, so that kind of gives us the how to calculate or how to relate and use the unit circle to come up with some of those special angles. We're not going to expect you to calculate for all kinds of angles, okay? We just gave you some special ones. And really, how many special angles are there? It's really only 3, and 2 of them are pretty much the same darn thing. So pretty simple in that situation. And when you combine it with your ideas about the reference angles. Let's see. Okay. So the only ones that we still haven't talked about, but now that we have the sine and cosine kind of done, we better lock it in. Let's see. Is what's the sine and cosine? Because there are some other angles that are important that really, when you get to calculus, you're going to be expected to know all of these, by heart without looking at anything. And some of these are really more important than other ones. And some of the really important ones here are the quadrantal angles. So, which means the angles that rotate you to the 4 quadrants. Okay, so let's just review. This is 1, 0. This is 0, 1 for its coordinate. This is -1, 0. And this is 0, -1. So if I asked you what the sine of 90 degrees was, you'd say, okay, well, that's the y coordinate in my thought process. That's the y over the r. And this is the angle. Okay, the angle of rotation. That's my theta. At theta. So I look at the y coordinate as 1. The radius is still 1 there. So this is equal to 1. If I said, what's the cosine at 3 pi over 2, okay, you'd have to know, okay, 3 pi over 2, that's one of the quadrantal angles. So the over 2 family is the quadrantal angles. And then, so we have to say, okay, cosine is defined as the x over the r at, now I think about this position, straight down. So that is going to be 0 in that situation. So the cosine of 3 pi over 2. So mentally, you're kind of thinking about it that way. I'm saying, okay, so what's the sine at pi? What's the sine of pi? So here I'm thinking about the y over the r. And here I'm thinking about the circle, and I'm thinking about the spinners pointing up straight out that way. So right there, it's equal to 0. What's the cosine at 0? What's the cosine of 0? So right there, I'm thinking that's the x over the r, and this picture at, and then if I think about my unit circle, pointing straight over. So that's going to be a 1 in that situation. The x coordinate there is 1. Okay, so that's getting your special angles from the unit circle. Thanks a lot, and keep watching.